Okay, this is chapter 5. 5.1 is about exponential expression and with integer exponents and also scientific notation. Okay, there are rules of exponents. So let's check the first one. A to the mth power times a to the nth power. Let's check this one. A to the third power times a to the fifth power. Then this is a product. So 3a's are multiplied for the first expression, and then 5a's are multiplied for the second exponential expression. So there are 3a's and 5a's. So altogether, how many a's are there? 3 and 5a's. So there are altogether 8 a's. So a is multiplied 8 times. So we can write it as a to the 8th power. That 8th power comes from adding two exponents, 3 plus 5. So a to the 8th power. Okay, so same base is multiplied 3 times, and the same base is multiplied 5 times. So altogether, this base is multiplied 8 times. So what we do is add the exponents. So the bases are the same. There are two exponential expressions with the same base and different integer exponents. Then what we can do is just add the exponents. Okay, for number 2. Okay, number 2 is the base is AB. There's a product A and B, product of A and B, and this is raised to the mth power. Then we can separate each factor in the denominator. Each factor in the base with the same exponents. So here is an example. Okay, let's say AB, product of AB is raised to the third power. Then this is equal to the base AB is multiplied 3 times. Then if we collect a's first, then there are 3 a's multiplied by 3 b's multiplied. So this is equal to a cubed times b cubed. So it's pretty simple. If a product is raised to a power, then assign this power to each factor in the base. So it will be 8 cubed times b cubed. Okay, even the quotient is same. If the base is a division like a over b, and this is raised to the third power, then this will be a cubed over b cubed. So just assign 3 to each numerator and the denominator, a cube over b cube. Okay, you can, for this one, we can multiply a over b 3 times. Then the numerator is a times a times a, b times b times b. So a cubed over b cubed. So we don't have to multiply all the numerators and denominators. We can skip all these steps. We can just use the formula. So assign the exponent to each a and b. Okay, how about number 3? Okay, number 3 is a to the mth power. An exponential form is raised to another power. So let's say a cube. Okay, a cube is raised to the 4th power. Then this means a cubed is multiplied 4 times. A cube, a cube, a cube. And then using the first property, if we multiply exponential form with the same base, then what we do is add all the exponents. 3 plus 3 plus 3 plus 3. So that equals a to the 3 times 4, so a to the 12th power. So if the base is an exponential form which has some power, and this base is raised to another power, then just multiply the exponents. So multiply the exponents, 3 times 4. So that is a to the 12th power. Okay, number 4. The fourth example, fourth rule is this is a fraction, and the numerator has the base a, and base a is raised to the nth power, and the denominator is a to the nth power. Okay, both the top and bottom has the same base a, Then you can move one of the exponential form into the other side. So let's say I want to move the denominator to the numerator, then that becomes a to the, change the sign of the exponent. Okay, that's important. Change the sign of the exponent. So once we move a position from denominator to numerator or numerator to denominator, then we got to change the sign of the exponent. Then by using the first rule, same base, so we add. Okay, we are multiplying two exponential forms with the same base a, then add the exponents. So the exponent will be m minus n. Okay, and this is pretty similar to example 7. Okay, example 7 is a to the negative mth power. Then this is equal to over 1. So we can move this to the denominator. Then the numerator is 1. The denominator, move it to the denominator, then change the sign of the exponent. M. Okay, for number 4, we can do an example like this. Okay, from the number 4. Okay, let's say a to the 4th power. Okay, let's say a to the 5th power divided by a cubed. Then the numerator is a product of a's. There are 5 a's. And then the denominator, there are 3 a's. Okay, when we simplify this fraction, we can cancel out each factor if that factor is in both numerator and the denominator. So we can cancel out 1a, another a, another a. So this is equal to a squared. Then basically, well, we got a squared by subtracting the number of a's from the denominator, the number of a's in the denominator from the number of a's in the numerator. So there were 5. There were 5 here and 3 here. So what we do is a to the 5 minus 2. So a cubed. 5 minus 3. So it will be a squared. Okay, so move up, then change the sign of the exponent. Then this is equal to a to the 5 minus 3, a squared. Okay, and number 5. Okay, number 5 is pretty straightforward. What we do is a over b. Let's say a over b is raised to the 3rd power. Then the numerator, then this will be a over b is multiplied 3 times. A over b 3 times. Then the numerator is, there are 3 a's, so a cubed, and the denominator is b cubed. So if we see this, the result is assign the exponent to each numerator and the denominator. So it will be a cubed over b cubed. All right, and then number 6. Okay, number 6 is, okay, here is a base, non-zero a. The base is not a 0. It is a number that is not 0. then if you raise to the 0 power, then it's always 1. So even x plus 1 raised to the 0 power, this is also 1. Okay, as long as the base is not 0, then if the power is 0, then the result is always 1. Okay. If the base is 0, then this is undefined. So we will assume that the base is not 0. Then something to the 0 power is 1. So even if the base is so complicated like this, y to the 5th power times x to the 8th power divided by x, y to the 4th power, whatever it is, if we raise this one to the 0 power, then this is equal to 1. No matter what the base is, if the exponent is 0, then the result is 1. Make sure the base is not 0. Okay, and the last one is number 8. And this is, okay, the base is a fraction, but the exponent is negative. Then we can change the sign of the exponent. Then what we do is we will make reciprocal of the base. So b over a. Okay, let's prove why we got this. Okay, just an example, 8 over b, let's say this is raised to the negative third power. Then we can assign the power to each numerator and denominator. Okay, negative 3 power. Then since the power is negative, we can change the position. So move the numerator to the denominator, then change the sign of the exponent, a cube. Even the denominator, move it to the numerator, then b to the positive 3 power. Then, since the powers are the same, we can put the bases together. So b over a raised to the 3rd power. Okay, so from here, we got this. So we can skip all the steps and write the results. Use the formula to write the results easily. Okay, so let's try another example. Let's say xy over z raised to the negative 3 power. Then we can rewrite as, make it positive power 3, then the vector reciprocal of the base. So z, and then xy moves to the denominator. Okay. Okay, so don't forget, okay, first we got to understand how we got these rules of exponents. So in this case, there are eight rules, 8 properties. So please understand first, and then memorize each. Memorize each rule. Okay, memorize each rules. So because we have to freely use these rules. So let's try an example. Okay, this is exercise 1, the example 1. There are 2, 4, 6, 7 examples. Okay, let's simplify each exponential expression. So this is all product. So let's put all the x's together. So x squared and x, and then y to the 4th power and 3. And write the number first. So 3 times. Okay, we can combine these two. So x squared times x is, the exponents of x is 1. So x to the, what do we do with this exponent? Add, right? So there are 2 x's and 1 x. So once we multiply this, there are 3 x's. So 2 plus 1 is 3, y to the 4th power. Okay, number 2. Number 2 is negative 2 times exponential form. So this is a power of another power. Power of another power, then what do? multiply the powers. 2 times 3, multiply the powers, then y to the 2 times 3x, 6th power. Okay, the next one. Okay, the base, look at the base. The base has two factors, -2 and y squared. So we can assign these three, the power 3 to each factor. So -2 is a factor in the base, so raise this -2 to the 3rd power, and then raise y squared to the 3rd power. Okay, then -2 cube is, okay, -2 cube is -2 is multiplied 3 times, so -8 times y to the power of power, so multiply 2 and 3, so 6. Multiply. Okay, and then the next one. Okay, 3x squared. 3x squared is just one expression, so 3 times x squared. That's it. And for this expression, also this base has two factors, -5 and x. -5 and x, so assign the power to each factor. So -5 is raised to the 3rd power, and x is raised to the 3rd power. Then simplify the numbers, 3x squared. Okay, -5 is multiplied 3 times, then negative. The sign is negative because negative is multiplied odd number of times. So -125 times x cubed. And then multiply the numbers. So 3 times -125 is -375. How about x? The factors. Okay, multiplying x squared and x squared and x cubed. And then x to the what? 2 plus 3. So what we do is add the power. So -375 x to the 5th power. Okay, the next expression is, okay, the number 14 and 7. We can reduce this. So divide each top and bottom by 7, then 2 and 1. Okay, so the numerator is 2. Okay, how about the a's? So in this case, a to the 5th power times, move this a squared from the bottom to the top. Then it will be a to the -2 power. Even b cube is same. So b cube in the numerator, move the b squared to the numerator, then it will be b to the -2. Then the denominator is 1. Since the denominator is 1, we don't have to write denominator. So the numerator is a to the 8 times 2 times a to the numerator, the exponent of a is 5, add the exponent, so 5 plus -2 is 3, and b to the 3 plus -2, 3 plus -2 is 3 minus 2, so 1. So that's the simplified expression. Okay, let's check the next one. Okay, the base is a fraction, so we can assign the power 3 to each numerator and the denominator. So the numerator is x squared, this x squared is cubed, and the bottom is 2y. The denominator is 2y, and this 2y is cubed as well. Then simplify the numerator and the denominator. So the numerator is power of power, so what we do is multiply the exponents. How about the bottom? Bottom is, the base is a product of 2 and y. So we will assign the power, the exponent to each factor. So the denominator will be 2 cubed times y cubed. Then the numerator, x to the 2 times 3 is 6 over 2 cubed is 8, y cubed. Okay, and then let's do the last one. Okay, x. So the numerator has exponential form with the base x, and denominator is the same. So what we can do is move x squared from the denominator to the numerator, then x to the nth power times x negative 2 power, y to the 3n, and then y to the, okay, move also y to the fourth power to the numerator, then y to the negative fourth power. Okay, then the product of two exponential forms with the base x, what we do is add the numerator, add the exponent of the base x. And how about the y? It's the same thing, add the exponents, so 3n minus 4. Then, okay, then this is the simplified expression. Okay, in this example 2, we gotta use the formula of this. So a to something to the 0 power is 1, and if the exponent is negative, then we can make the positive exponent by moving the position of that exponential form to denominator or numerator. So since this is in the numerator, move it to the denominator and change the sign of the exponent. Okay, or if the base is a fraction, okay, it doesn't have to be a fraction, but there's a base here, and the exponent is negative, then you can make the exponent positive. Then what do we do? Make the reciprocal of the base, so b over a. So we will use these three properties to simplify this example. Okay, a to the 0 power is, let's say this is 1. Okay, how about the question should be 3 to the 0 power. So 3 to the 0 power is, of course, 1. How about 3 to the negative 2? The power is negative 2. And then you can move this one to the denominator, so 1 over 3 to the second power. So negative 2 becomes positive 2. I mean the exponent, the sign of the exponent changes. Then 1 over 3 squared is 9. Okay, the next one is the exponent is negative 1, so we can make it positive 1. Then what happens to the base? Make it reciprocal. So 4 over 3. So 4 over 3 to the first power is 4/3. Okay, how about this example? How about negative 10 to the negative 3 power? Okay, then this is, the negative sign is outside the exponential form, outside. So the result is negative, and 10 to the negative 3 power will be moving to the denominator, then 10 cubed. So the result is 1 over 1000. So 1 over 1000 is negative 0.001. It's the same. Okay, so make sure that this negative sign is outside the base. Okay, I mean outside the exponential form. The base is not, okay, be careful. This is totally different. This is different. In this case, the base is negative 10. Base is negative 10, but this one, the base is 10. That's different. Okay, then let's try another one. But negative 20 to the negative 2 power. Then this negative is outside. So same thing as this one, negative times 20 to the negative second power. The negative, the parenthesis is 1 over 20 squared. So negative 1 over 400. Okay, so keep in mind that negative is outside the exponential form. Okay, how about the 0 power? The 0 power. So here's another example. What if the base is x squared plus 1 to the 0 power? Then the base cannot be a 0, right? The base cannot be 0. We will assume that this is not 0. Anyway, this base is not 0, so something to the 0 power is always what? Yes, it is 1. Try another one. How about x over 3 to the power is negative 2? Okay, then this is equal to what? Change the power, sign of the power, then reciprocate the base, 3 over x. Okay, then assign each power to this. Then 3 squared, x squared, so 9 over x squared. Okay, in this example 3, the expressions in A and B look similar, but they are different actually. So the first one is, okay, this is a product of 2 and the exponential form. So 2 times x to the negative 1 is, you can move it to the denominator, then x to the first power, then the numerator is 2, then the denominator is x. If the power is 1, then we usually don't write this power, 2 over x. Okay, the second one is, the base is 2x. So what we do is move this whole base to the denominator. And then the power is positive 1. And since the power is 1, we can just get rid of this power, so 2x. Okay, when we simplify an exponential form, we usually make the sign of the exponent positive. So the denominator has negative exponents. So how can you make this negative exponent positive? Just move the exponential form to the other part. So move it to the numerator. So 3 times x to the, now the power becomes 2, and denominator is 1. So you moved this exponential form to the numerator. So 3x squared. Okay, the next one is same thing. The exponent is negative 2. So why don't we move this exponential form to the numerator? Then 3x. 3x is the base, and the power, it becomes positive 2. Then assign the exponent to each factor in the denominator. So 3 squared times x squared. So 9x squared. Okay, this time let's try to simplify exercise in page 232. So let me do the even numbers. So number 26 is, okay, make the exponent, negative exponent to positive. So we can move this exponential form to the denominator. Okay, 3y, in this case, the 3y is not the base, y is the base. So if you rewrite it, this is same as 3 times y to the negative 3 power. Okay, so the base is not 3y, be careful. Base is only y, not 3y. Then 3 over, move this one to the denominator, then y cubed. So this is its simplified form. Okay, the second one, number 28 is, okay, now the base is 11x. So if you want 11x to be a base, then you have to put parentheses. So we know that 11x is the base. Then move that one to the denominator, 11x, to the first power. Then first power, if the power is 1, we don't need it. So it is 11x, 1 over 11x. Okay, the next one is the same. The base is 5u, and the exponent is negative. So move this whole thing to the denominator. So 1 over 5u raised to the second power. Change the sign of the exponent. So negative 2 becomes 2. Then 1 over the denominator, assign the power to each factor. 5 squared times u squared. Then 5 squared is 25 u squared. Okay, the next one. There are two exponential forms and the same base. So what we do is add the exponent. So z to the power is negative 5. It's not negative 5. Power is 5 minus the second, this one, negative 3. So that is equal to z to the g squared. Okay, number 34. The denominator, now the exponent in the denominator is negative, so move it to the numerator. So 4 times y to the first power, then 4y. Okay, number 36. Okay, something to the 0 power is what? This is equal to 1. Okay, then that is 1 over x to the negative 3 power. But there is a negative power, so move this exponential form to the numerator, then x cubed. Okay, number 38. Okay, the numerator is this. Okay, the denominator has one exponential form and its exponent is negative. So move this one to the numerator. So 3 times, it will be 3 times 3a to the third power. Change the sign of exponent. Then this is equal to 3 times. Okay, assign 3, the power 3 to each factor in the base, 3 and a. So 3 cubed times a cubed. Then 3 times 3 cubed is 27, a cubed. So 27 times 3 is 81, a cubed. Okay, now 40. The 40 is, the denominator is something to the 0 power, something to the 0 power. So this will be equal to 1. So what we have is 9n to the negative 2 power over 1. And the numerator has negative power, so move this whole thing to the denominator. Then 1 over, this exponential form to the denominator. Then 9n raised to the second power. And then since there's a power, assign the power to each factor. So 1 over 9 squared times n squared. So 1 over 81 n squared. Okay, 42. 42 is the base is a fraction and the power is 2. So we can make a positive power and then reciprocate the denominator. Then assign the power to each numerator, the denominator. So z squared over 4 squared. Then z squared over 4 squared is 16. Okay, let's simplify these examples. And then, so when we simplify, make sure that the power is positive. Okay, now the base, in this case, the base is negative 5 times x to the negative third power. So assign this power to each factor. So there are 2 factors, negative 5 and this. So negative 5 raised to the second power. So assign this one to each one. And the next is x to the negative 3 power raised to the second power. Then negative 5 times negative 5 is 25. And x to the power of power is what? Multiply the exponents. So negative 3 times 2. So 25x to the negative 6 power. Okay, now this x has power negative 6. The power is negative. So move this exponential form to the denominator. Then 25 over, move it to the denominator. Move it to the denominator. So x to the 6th power. Okay, the next one. The negative sign is outside the exponential form. Okay, so leave the negative sign. And the power is negative, so make it positive. Then what happens to the base? Make it reciprocal. So y squared over 7x. Then negative. Now we can assign this power to each numerator and the denominator. So y to the 4th power over 7x. The whole denominator is 7x, so 7x to the second power. Okay. Is it, wait a minute. Right. Okay, here, let me write the step each step. So y squared is raised to the second power. And the denominator, 7x, is raised to the second power. Then the numerator is, make sure the negative sign is there. So power of power is product, multiply, 2 times 2. And the bottom is assign the power to each factor because the base is a product of some factors. So 7 squared, x squared. So the result is negative y to the 4th power over 7 times 7 is 49 x squared. Okay, the next one. Okay, the numerator and denominator, we can simplify with numbers first. So 12 divided by 6 is 2, 6 divided by 6 is 1. So we have 2 in the numerator, 1 is the denominator. Okay, how about x? Okay, move. Okay, which one do you want to move? You can move this negative exponent to the numerator. So x squared times x to the 1st power. You can move this one to the denominator, then denominator is y squared times y to the 4th power. Okay, okay, you can decide. Okay, we can move exponential form if the exponent is smaller than others, smaller than the other one. Then move the exponential form, which has the smaller exponent, to the other part. So negative 1 is less than 2, so move this one. And negative 4 is less than 2, so move this exponential form. Okay, then the numerator is 2x, 2 plus 1. 2 plus 1, the denominator is y to the power is 2 plus 4. So 2x cubed over y to the 6th power. Okay, let's do the next one. Okay, this example 6 looks so complicated, but don't worry. We will just apply the rules step by step. So in this case, you can simplify the base first. You can simplify the base and assign the power, or you can assign the power. It doesn't matter. So in this case, why don't we simplify the base? Okay, let's simplify the base. The power is negative 3. Or you can make it positive by, or you can, okay, I think this is better. So why don't we change the sign of the exponent, 3. Then we can switch the numerator and the denominator. So switch the numerator and the denominator. Okay. And then, why don't we simplify the base? Simplify the base. So 4 divided by 4 is 1, 8 divided by 4 is 2. How about x? Okay, the x terms are what? I mean the x factors. The power is 3 and negative 1. So we want to move the exponential form which has smaller power. So move this one to the numerator. Then x cubed times x to the 1st power. How about y? Okay, 2 is smaller than 4, so move y squared to the denominator. Then y to the 4th power times y to the negative 2 power. Okay, negative 2 power. Then this is equal to, the numerator is x to the 3 plus 1. Where 3 plus 1 is 4. How about the denominator? 2 times y to the 4 minus 2 is 2. Cube. Okay, next step is we can multiply the power to, assign the power to each numerator and the denominator. So x to the 4th power raised to the 3rd power over the denominator is the same. Raise the denominator to the 3rd power. Okay, and the numerator is power of power, so multiply the powers, exponents, multiply the exponents, 4 times 3, and the bottom is assign the power to each factor. So 2 cubed times y squared cubed. Then the numerator is x to the 3 times 4, 12. The bottom is 2 cube is 8. And then y to the what? 3 times 2, power of power. So multiply the powers. 3 times 2 is 6. Okay. Now let's do next one. Okay, something to the 0 power is 0. So y to the 0 power, the base, okay, this is one exponential form, y to the 0 power. Okay, 3xy is not a base. If we want 3xy to be a base, then you have to put 3xy to the 0 power. But this is not, there's no parenthesis. So 3 and x are separated. So y to the 0 power, this one is 1. How about the denominator? Okay, now 5y is the base because there is a parenthesis and raised to the 0 power. So this exponential form is 1. So what we have is 3x over x squared. And then there are x terms in both numerator and denominator. So why don't we move this one to the denominator? So 3 over x squared times x to the negative 1. Because the power of x is 1. Then 3 over x. 2 minus 1 is 1. 2 minus 1 is 1. So 3 over x. Okay. So it's very important that that you have to exercise. Okay, you have to do lots of questions provided in the textbook. So be familiar with the formulas. You know, there were like 8 formulas, right? So you must utilize the formulas at any time. So practice, practice, practice. Okay. Okay, in this exercise, we will learn how to, about the scientific notations. Okay, scientific notation is this. Okay, when a number is very large or very, very small, then we can write it as 10 to the nth power. So here's a number a, multiplied by 10 to the nth power. And this number a is, the range of this number a is always greater than or equal to 1 and less than 10. So a is like up to 9.9999 something. Okay, and then the exponent of 10 is just an integer. It can be positive integer or negative integer. So let's convert this number to in scientific notation. Okay, so this will be, the scientific notation is the value a is always greater than or equal to 1 and less than 10. So let's move this decimal point to the right until we reach to the next non-zero digit. So move this decimal point to the first non-zero digit, which is 6. So it goes between 6 and 8. So you can write the number 6.84 times 10 to the nth power. Now the exponent is this. Okay, we moved, how many places did we move? 1, 2, 3, 4, 5. We moved 5 places to the right. Okay, that means we're going to write the power will be 5 or negative 5. 5 or negative 5. But in this case, the exponent is negative 5. Because okay, we have a number 6.84. 6.84 will be very small, like this. So if we want to make this number to be very small, then the power has to be negative. Okay, the power has to be negative. Okay, let's try the next one. Okay, move the decimal point. Decimal point is here, so move it to the left. 1, 2, 3, 4, 5, 6, 7, 8. So we moved 8 places to the left, and then the point will be 9.37. You don't have to write zeros after 7. Okay, and then multiply by 10 to the what power? We moved 8 places, so it's going to be 8 or negative 8. Then what is the sign of the exponent? Okay, let's check this. I want to make this number large, very, very large. Then the exponent is positive. So it's going to be positive 8. So in order to make this number to smaller then the power is negative. If you make the number larger, then the power exponent will be the positive. Okay, so move the decimal point all the way to the right after the first non-zero number. Okay, in example 8 is vice versa. So from the exponent, from the scientific notation, write a number. Okay, so I'm multiplying this by 10 squared. Okay, 10 squared means, this is positive, so we are making this number large. How large? Move 2 decimal places to the right. So make it large, make this number large, and move how many spaces? 2 spaces. 2 places. 1, 2. So it will be 2, 4, 8.6. So move 2 places to the right because we want to make this number large. So the decimal point should go to the right. How about the next one? Okay, multiply this number by an exponential form whose exponent is negative. If it is negative, then we are making this number smaller. So the decimal point must move to the left to make it smaller. So we need to move 6 places to the left. So let's write 6 zeros. 6 zeros. And then move the decimal point from here to the left 6 times. 1, 2, 3, 4, 5, 6. So this is number that represent this scientific notation. Okay, then next example is calculating scientific numbers in numbers. So we have to change these numbers into scientific notation. So it is much easier and simpler sometimes. So in this example, let's convert each number, write each number in scientific notation. So the first number is 2.4 times 10 to the, okay, the decimal point was here, 369. So 10 to the 9th power. Then multiply by 4.5 times, multiply by 4.5 times. Okay, move this one. 1, 2, 3, 4, 5, 6. So 10 to the negative 6th power because we want to make this number smaller, so the exponent is negative. Over. Okay, in the denominator is move this one. 1, 2, 3, 4, 5. 5. So 3.0 times 10 to the, is it 5 or negative 5? I want to make this number smaller, so it's got to be negative 5. And the next one is move from here 1, 2, 3. So 1.5 times 10 to the positive 3 or negative 3? Positive 3, because make this number larger, positive 3. Okay, the next is multiply the numbers or simplify the numbers. So let's simplify the numbers and then the numerator as well. Okay. And then look at this. Okay, 1.5 and 4.5. So multiply 1.5 by 3. 1.5 by 3 is 4.5. So dividing 4.5 by 1.5 is, this is 3 and this is 1. So 4.5 over 1.5 is 3. And this 3 cancel out. So we have 2.4 multiplied by 10 to the, okay, the exponential form has all tens. The bases are tens. So why don't we put all the exponents? So 9 minus this one 6, and then move this one to the numerator, then plus 5, 3 to the numerator, then minus 3. So this is equal to 2.4 times 10 to the 9 minus 6 is 3, and 3 plus 5 is 8. 8 minus 3 is 5. So this is the scientific notation. Okay, so the numbers is Or you can do this way. Number is 2.4, and the numerator is 10 to the 9th power, and the minus 6. And the denominator is 10 to the negative 5 plus 3. So 2.4 times 10 to the 10 cube over 10 negative 2. Then move this one to the numerator, and 10 squared. So that is equal to 2.4 times 10 to the 5th power, 3 plus 2, 5th power.